This is a short video with the solutions to Thursday's revision work. It is the 2017 Examcraft mock paper 2 question 2 and it's on probability. In part A we have an equation using combinations. So 15 choose or plus 3 equals 15 choose 4 or minus 13. They want us to find or, and they're just specifying first of all that it's not as simple as saying or plus 3 equals 4 or minus 13. So the first thing that I want to point out is that generally in the case where you have two combinations being equal, if the n values are equal, then we have two possible cases. Either A equals B, which they've ruled out in this case, or A plus B equals to n, which is the case that we're going to use. So I'm going to add the or values from the n choose or, and we've got or plus 3 plus 4 or minus 13 equals to our n value, which is 15. And at this point then it's just simply using a bit of algebra to work out the or. And we end up with or is equal to 5 at the end of that. Just a little side note there on that n choose A equals n choose B. So for example, 7 choose 2 equals to 7 choose something else. What might that something else be? It'll be 5 because 2 and 5 make 7. 100 choose 99 equals 100 choose something. What could the something be? Easy, it's 1 because 99 and 1 make up 100. And you can test this quite easily on your calculator. 100 choose 99 works out to be 100, and 100 choose 1 also works out to be 100. Okay, moving on to part B. Part B is a few sections, and in these questions we have a bag of discs, 5 yellow, 3 green, 6 blue, 2 black, and we want to make selections from the bag of discs. It's a good plan to note first of all how many discs there are in total. Now, because we're selecting various different colour discs from the bag in each part of part B, it's worth our while doing this using combinations. It makes the question a lot less cumbersome than it would otherwise be. This is kind of less writing if we use combinations than if we use other methods. So let's have a look at how this would work. So in part 1 we want to select 4 discs and we want them all to be the same. We want to find the probability of that happening. So we're trying to find the probability that we've got 4 yellow, or 4 green, or 4 blue, or 4 black. Just note that the word or in probability indicates that we want to add to get our answer. So first of all, probability of getting 4 yellow. Well, notice how we've got 5 yellow discs in total and we want to select 4 of those. Of course, selection is the whole idea behind being able to use combinations. So I've got 5 yellow discs and I want to select 4 of them. And I don't want any other colour. So from the remaining 11 discs, they're green, blue and black, I don't want to select any. So I've got 11 select 0. Now this isn't strictly necessary to include this, but I'm going to include it just so we can see a pattern through our answers in parts 1, 2 and 3 at the end that might be useful to you. This calculation lets me find all the different ways that I can select 4 discs from the bag. But now it's a probability that I want, so it's going to have to be over the total possible number of ways in which I can select 4 discs. So of course, since I've got 16 discs in the bag in total, and I just want to pick 4, then the bottom of my probability should be 16, choose 4. Moving on through my subsequent probabilities, I'll approach them in exactly the same way. Just spotted something there. I've got 3 green, not 4 green, so I'm going to put a 3 in here. Actually, no, I'm not. I wanted 4, don't mind me. Let's have a think. Right, so I want to pick out 4 discs. I want them all to be green. Is that even possible? Well, if I want to pick out 4 discs, but I've only got 3 green discs, I actually can't do this. So that's just not going to be a runner. On I go to my blues. Let's have a look. So I've got 6 blues in total, and I want to select 4 out of those. I want to select 0 of the remaining 10 discs, and just like before, the bottom of my probability will be 16 choose 4. Now again, moving on to my last probability here, I want to find the chances that I might pick 4 black discs out of the bag. Well, I've only got 2 black discs, so this obviously again is not a possibility. So I don't even need to do a calculation for that one, it just couldn't happen. You can put a 0 in there for that probability if you want. And then I can just go straight to my calculator and add these 2 probabilities to get my final answer. And the answer comes out as 1 over 91. Now I'm perfectly happy to leave the answer as a fraction, unless they say to me in the question to write it as a decimal or percentage. 1 over 91 is absolutely fine. Having a glance back for a moment to the layout of my calculations for both parts of this, let me just explain to you what I've done on top here by putting in the 11 choose 0 and putting in the 10 choose 0. You can see here how the 5 and the 11 make the total of 16, and the 4 and the 0 make the total of 4. It's the exact same thing here. The 6 and the 10 make the total of 16, the 4 and the 0 make a total of 4. By doing this, in the layout of a probability question with combinations, I'm making sure that I'm not leaving out any options in the numerator calculation of my probability. Again, like I said, it's not essential that you do it here because I don't want to choose anything from those 11 discs. 11 choose 0 just works out as a calculation of 1 anyway. So putting it in or leaving it out isn't going to affect your final answer, and the same here. But we'll see in part 2 and part 3 of the question how it can be useful to include this little extra bit as we calculate our probability using combinations. So let's go on to part 2. In this part of the question, I once again want to select 4 discs, but this time I want the discs to all be different. Now I've got 4 colours that I'm choosing from, yellow, green, blue and black. So I'm essentially going to want one of each of the colours. So again, I've got probability, so I'm setting up my fraction. And what am I going to have? Well, I've got 5 yellows and I want to select one of those. And I've got 3 green and I want to select one of those. And I want to select one from the blue group. And I want to select one from the black group. I still had 16 discs to start out with, and I wanted to select 4 discs in total. So from my 16 discs, I'm selecting 4, and that 16 choose 4 represents all the different ways in which I could select 4 discs from that bag overall. Now again, just notice when I look at my values here, 5 and 3 and 6 and 2 add up to give me the 16, and 1 and 1 and 1 and 1 add up to give me the 4. So I'm pretty confident so that I'm doing my calculation correctly. I'm going to go to my calculator and I get an answer of 9/91. Okay, finally on to part 3 then. I want to select 4 discs again from the same group, and this time I want to find the chances that 2 of those discs are black. Now it's really important that, yes, the 2 discs that are black are important, but the other 2 discs that I'm selecting are also important. I'm going to have to factor them into my probability calculation. So really what's happening here is that I've got 2 that are black and 2 that are some other colour. Again, don't forget that and means that you're multiplying. So again, getting a probability, setting up my fraction. So, okay, I want to find the probability so that 2 are black. So if I look back to my information, I've got 2, oh, it's a bit further up there. I've got 2 black discs and I want to select the 2 of those. So I'm going to say 2 choose 2. Now don't forget, I've got 16 discs overall. So I'm selecting 2 of the black discs, but I also have to select 2 of the remaining discs. There are 14 discs remaining when I discount the black discs, so that's 14 choose 2. And again on the bottom, I want to select 4 discs from the 16, so 16 choose 4. And again, like before, you can see that 2 and 14 make up the 16, and 2 and 2 make up the 4. And this part 3 of this question is probably, I suppose, the part where it's really most useful to note that connection between the values in your numerator and the values in your denominator, because the way the question is worded, it makes you just think about the black discs. It's very easy to forget about the other discs that you must select that aren't black. But by remembering this little rule that the n's have to add up to the n here and the r's have to add up to the r here, it kind of makes sure that you don't forget about that part of the calculation.